All right, just a second example for finding all that key information about some quadratic function. Let's go ahead and start with whether it opens up or down. Okay, so I recommend, if you're working with this, go ahead and graph this function on your calculator so you kind of get a feel for what the graph should look like. It is going to open down. All right, it's going to be opening down because this 3 right here is negative. Because that leading coefficient is negative, it's going to be opening down. 2, the y-intercept on this one is going to equal 0. So to find the y-intercept, you plug in 0 for these x's right here, and that's all you're left with. All right, everything goes to ash, and so you're left with y equals 0. All right, there's not a c term, a constant term on this one, so you're not actually going to have any number. You're just going to have 0. All right, the x-intercepts for this one are not going to be as bad as that last one because we're going to figure it out by factoring. Okay, this one is factorable. Negative 3x squared plus 4x. There we go. So we plug in 0 for y to find the x-intercepts. And you could use the quadratic formula, but it's easier to solve this one by factoring. Both of these terms have an x in common. And what I'm going to do here is I'm going to factor out a negative x. Right. If I factor out a negative x, it's going to leave me with a 3x minus 4. All right. And now that it's in factored form, I can set each of those factors equal to 0 and solve for x. So negative x equals 0, therefore x is equal to 0. That's one of my x-intercepts. X equals 0. The other one, 3x minus 4, set that equal to 0. And when you solve this one, you're going to move the 4 to the other side, plus 4, and then divide by 3. So x equals 4/3. Or you could say, 1.33. 1.33. Cool. Okay, and then fourth, vertex. Nice. All right, so to find the vertex on this one, we could complete the square, but it's actually going to be more difficult because we actually have a leading coefficient here that's not 1. So if you want to do the completing the square, it's a little bit tougher. That negative b over 2a formula, that's going to be the simpler way. To find the x part of the vertex, we're going to do negative b over 2a. So negative b is going to be negative 4 over 2 times a, which is negative 3. The negatives are just going to cancel out, so you're going to be left with 4 over 6 or 2/3. Okay, that's going to be the x part of our vertex. And then to find the y part, all right, take that 2/3, take your x part, and plug it back into the function. So it's going to be negative 3 2/3 squared plus 4 times 2/3. Okay. You could figure out all this stuff by hand, of course, but I got my calculator. Let me do that. Okay. And this is all going to come out to 4/3, positive 4/3. So my vertex is going to be 2/3, comma, 4/3. That's my vertex. Cool. All right, now with all this information right here, I'm going to go ahead and sketch a little picture of the graph without the calculator, but hopefully my graph matches with what you get on the calculator. So if I were to graph this, switch colors here. Okay, so 2/3, 4/3 would be a little bit to the right and then up to the 4/3 mark. So right a little bit and then up a little bit. And then I know the function's opening down. What else do I know? I know that it has a y-intercept of 0. That's actually one of its x-intercepts as well. And what was my other x-intercept? 1.33, or 4/3. Okay. It's going to be somewhere in there. And it's opening down. So the graph of the function, okay, it may not look exactly like mine, but it should be something like this. You know, the vertex is in quadrant 1, and it's opening down. All right, the last thing here, we'll identify the range. So because it's opening down, the y values are from -infinity. Okay, -infinity up to whatever that y value is, which is going to be 4/3, and we'll do a bracket there. Okay, that's our range. We'll say y is less than or equal to 4/3, or 1.33.